Rural communities on the Navajo Nation do not have access to modern water and electrical systems, therefore lack access to safe drinking water. Plentiful, unregulated groundwater sources are used for potable uses and are not routinely tested for legal EPA water standards. Consequently, chronic exposure to subpar water can have negative health impacts to Navajo residents. Membrane water filtration treatment is a low-energy demanding technology and has high rejection characteristics for molecular ions. The purpose of the NanoFiltration unit is to provide a water treatment solution in providing safe water to rural Navajo community members. This video will identify system components and explain how they work together, as well as provide information for the basic startup, operation, and maintenance procedures that can be used in conjunction with the operational manual. The unit system has two independent processes and they can be visualized as flow diagrams. The two flows in the diagram are the electrical path and the water stream. All the energy necessary for system operation is collected from the sun. The system uses solar panels to generate electricity for various system components. The energy collected from the solar panel array is sent to the charge controller. The charge controller helps the system regulate the collection and storage of electrical energy. From the charge controller, the electricity is sent to the power controller and the pump controller. The power controller is connected to the battery compartment and is responsible for turning the system on or off. The pump controller relays electrical power to the water pump and the power usage is tunable. The pump is mostly powered directly by the electricity generated by the panels, and battery storage is only available for instances like a passing cloud that reduces the output of solar panels. The system operates at an average of 1100 watts. Finally, the UV lamp that is used for disinfection for purified water draws power from the battery compartment. Water first enters the system from an outside source and is stored in the unfiltered water storage tank. The water is then pumped from the unfiltered water storage tank through the pump to the rest of the system. The pump provides the pressure necessary to achieve desired performance. From the pump, the water is pumped through the pre-treatment filters. The water then passes through the nanofiltration membrane units. The clean water is then sent to the filtered water storage tank. Finally, the water can be collected from the disinfected water faucet or from the collection pipes located behind the filtered water storage tank or at the rear end of the trailer near the feed holding tank. To set up the water line for operation, first make sure an adequate amount of water is in the feed tank and all valves in the system are closed except for the main valve at the feed tank. Secondly, open up the valve between the pump and pre-treatment filters. The chosen membrane will need both valves before and after opened. The brine and the permeate are the two output streams leaving the membrane vessel and each have a flow meter. The brine stream has two valves, the bypass valve and the pressure control valve that need to be opened prior to pump start. The permeate line goes to the permeate tank for use. Lastly, the permeate tank valve can be opened to allow dispensement at 3 locations, one next to the permeate tank, another at the rear of the trailer, and the third at the UV light for immediate consumption. To energize the system, we need to connect the solar panels to the entire nanofiltration unit. First, we set the main circuit breaker to the on position by pushing the lever up. Second, we ensure that the 3 component circuit breakers are on, also in the up position. Third, we wait for the charge controller to boot up. The controller will start to display information such as the amount of watts that are currently available in the unit. Lastly, the pump controller will have green colored lights indicating that power is available for the pump. Then, moving the toggle switch to the on position will activate the pump. Adjustment of the pump operating speed can be controlled by the fine-tuned dial using a flathead screwdriver. Once the pump is in operation, the pressure and feed flow rates will need to be adjusted manually using the valves located on the brine line after the membrane vessel. The operational water pressure can be read off of the brine stream pressure gauge located before the valve and flow meter. Gradually close the brine valve until the applied water pressure reaches between 60 to 70 psi. As you constrict the brine stream valve, the pressure increases and will cause more water to flow through the membrane. To ensure longevity of the membrane, it is recommended to always have more brine flow than permeate flow at all times. This means that the brine flow should operate at 6 gallons per minute and the permeate flow should run at 1.5 gallons per minute. These can be seen on the brine and permeate flow meters. You will then hear water flowing into the holding tank. As mentioned before, filtered water can be accessed at 3 different points on this unit. First, for immediate personal consumption, the faucet to the left of the holding tank can be used. The water goes through the solar-powered UV light, which is also known as a secondary treatment for the permeate water. Secondly, for large containers that need to be filled, there is a bigger permeate flow pipe on the back of the holding tank. Turn the valve so that it is parallel to the pipe to allow water to flow. The third location is at the rear end of the trailer, near the feed holding tank. First, you open the far left valve, then close the valve next to it. Finally, you open the permeate flow pipe to allow water to flow out. For data collection and analysis, we need to ensure that the NanoFiltration unit is running the way it should be. First, we need to determine some parameters. We can find the reduction of water conductivity through a surrogate test for contaminant removal. This is done by the conductivity meter, which obtains data that will then be used to calculate the rejection percentage of the system. For this, we will use the conductivity meter to test water from both the feed flow and the permeate flow. The influent concentration will be a water sample from the 325-gallon feed tank, whereas the permeate water sample can be taken from the sample port located between the permeate flow meter and the permeate storage tank. The conductivity information of each feed that we get from the meter will then be inserted into the percent removal equation. Ultimately, we want a percentage between 30 to 60% for the NanoFiltration 270 filter and a 50 to 90% for the NanoFiltration 90 filter. This unit can produce up to 1,500 gallons per day of potable water, which is safe for human consumption. The volume of the brine water from the NanoFiltration unit will be large, therefore finding an appropriate disposal method is essential. We know that most brine water can be applied to salt-tolerant crops and can be used for household cleaning. However, special care must be considered for brine containing hazardous contaminants. There is current research looking into brine treatment that can remove hazardous contaminants from the brine stream. Membrane water treatment, such as this solar nanofiltration unit we've shown in this video, can be an effective solution for issues like the lack of available potable water in rural areas and the lack of electrical infrastructure. The solar nanofiltration unit shown in this video is funded and built with a grant from the National Science Foundation. This is a collaboration between the University of Arizona, the Indigenous Food, Energy, Water Security, and Sovereignty Nexus, better known as the Indige-FEWSS Nexus, Graduate Research Fellowship, as well as the University of Arizona Chemical and Environmental Engineering Department. We hope that you found this video very informational and easy to follow. Thank you for taking the time to listen. If there are any additional questions, please feel free to contact the Indige-FEWSS representative listed.